So in this video, we'll be discussing May-June 2025 Pure Mathematics 1 questions for paper 1-2. So let's have a look for first question. We are given a diagram here. Okay, so let's have a look what are they talking about. So the diagram shows the graph with the function f and also the function g. So you can see this is function f and this is function g. They want us to describe a sequence of two transformation. Please highlight the keyword two transformation here, which transform the graph from function fx to the graph gx. Make clear the order in which the transformation should be applied. Right, so there are two transformations involved in changing the function f become the function g. So let's have a look here. And what should we do basically? So very obvious, and you can see that there's a translation, right? Because there's a translation, looks like translation. Okay, you're having the fx on top, then seems like we are going to move it down to a lower value, okay, to the lower part of the graph. But although it seems like a translation, before that, let us figure out, is there any other type of stretching or reflection or what? There's no reflection, very obvious, but we know that there's a stretching. It is because of, in the original graph, okay, so in the original graph here, basically we are having 3, right? So you can see from the maximum point to the minimum point. All right, in the graph, what do we have here is we are having 3 units. This is the 3 units. Okay, but if you try to have a look for the gx, the maximum point go down to the minimum point, what do we have here? So we are having actually 1, 2, 3, 4, 5, 6 units. And very obvious, from 3 units to 6 units, right, it is a stretch. So basically this is a stretch, okay, with a factor 2. Alright, so after we stretch, when you are having the stretching with factor 2, right, that means you are pulling it in the y direction, yeah, so in y. Okay, so in y with a factor 2, that means you are trying to pull the graph longer. When you are trying to pull the graph longer, it will actually affect your y coordinate. Okay, so when it affects your y coordinate, so we are having a new graph lah. Alright, so let's start with the very first transformation here first. So we have stretch in the y direction first with a factor 2. So what will I write out is like this. I will write out in this way. Maybe I can put it on this side. Okay, so the very first transformation is we are having the stretch in y direction or parallel to the y-axis. Okay, with a stretch factor 2. Okay, so like what I told you just now, this particular transformation means that you are making the 3 unit of graph in the y direction become 6 units of the graph. Okay, and it will affect our y coordinate, right? So what does it mean? It means that when you are having the stretch in the y direction for factor 2, you need to see what is your graph after this stretching, right? So originally you are having the value here, which is a positive 6, right? So when you're having a stretch factor 2, that means when you are trying to multiply the 6 with a 2. So originally this is the coordinate for 0, 6. So after the stretching, I will be having 0, 12. I write in the green color part so that you know what happened here. So let's have a look for this particular part. Then this one, originally you're having 5 for the y value, right? So after the stretching, this particular value, the 5 here, you need to multiply with 2. So 5 times 2 is a 10. So for this question, for this particular point, you're having -2 and also the 10 after the first transformation. Okay, then simply happen here. What happened to this point? Let's have a look for one more point here. So for this point, originally it is at 3, right? The y value equals to 3. After the first transformation for the stretch in the y direction, x value, x coordinate will not be affected, but it will become 3 times 2, which is a 6. Alright, so please try to imagine that after the transformation, these are some of the examples for the points. okay, for the first transformation, which is the stretch in the y direction with a stretch factor 2. Okay, then now, after you transform them in the stretch for the y direction, and now, from 0, 12, how can I move it become this one, which is basically the 0 and also negative 2. So you try to imagine from 12, how can you make it become negative 2 here? So basically you are moving it downwards for 12 units, right? Or is it 14 units? Sorry, it should be 14 units because 12 plus another 2 units here, so it should be a 14 unit. Same thing happen here. If you try to check for another point, this point is after the stretch one, right? Then what is the next transformation? Then you compare it with this particular point here after the transformation. And if you have a look, what is the coordinate for this one? It is still negative 2, but the y coordinate become negative 4. So what's the difference between the 10 and also the 4? So basically, again, you can see that we are trying to translate the graph 14 units downwards. So you can check it and double confirm your answer by checking on all the reference point here. It will help a lot, right? So like the 3 and 6 here, also, you try to compare it with this particular point. The x coordinate is still a 3, but the y coordinate become negative 8. So again, so you double check and see 6 become negative 8. It is 14 units apart, right? So that means we are trying to move the whole graph 14 units downward. So how can we write out the answer for this one? So basically move down means translation. Okay, with the vector, didn't move the x, right? You didn't move it left or right. So the value for the x is 0. And then we are moving the whole graph 14 units downwards. So to move the graph 14 units downward, when we want to write out, it should be negative 14. So this is the two transformation that we have in changing the graph of fx become gx. Right? Then when you are trying to write the answer, right, there are a few important keywords that you must always show. For first one, please make sure you show what kind of transformation do you have. So stretch is a keyword, and you need to tell them also what is the direction of your stretching. It can be horizontal stretch, it can be vertical stretch. So for this one, it is a vertical stretch. Then what is the value for the stretch factor? Then for translation part, you need to show them the translation. At the same time, also what is the vector for your translation here? Okay. Yeah, so this is what we have for question number 1. Okay, so now we are at question number 2. They want us to find the coordinate of the intersection points of intersection for the curve and also the line with the equations like this. Oh, so this question is very straightforward. Every time we want to get the intersection point, we just try to solve the equation simultaneously, right? Okay, so for first curve that we have here is 2xy plus 5y squared equals to 24. And I will put this as the first equation here. And my second equation is a linear equation where it looks something like this. So I'm having 2x plus y plus 4 equals to 0. And I would like to change it become 2x equals to negative y and also negative 4. This is my second equation here. And I want to sub the second equation into the first one to solve them simultaneously. Alright. So for 2x, I will replace it by using negative y minus 4 multiply with the y. So 2xy plus 5y squared equals to 24. Then you try to simplify the terms here and equation here. Okay, then if you have a look for this equation, yeah, basically it is quite obvious that it is a quadratic equation, right? Negative y squared plus 5y squared, you'll be having 4y squared minus 4y. Move the 24 over. Yeah, so it's very obvious. You can see very clearly that it is the quadratic equation in terms of y. And next, let us solve the equation. You have to factorize them. I'm having y and also the y here, 3 and 2. Should be negative 3, positive 2. And my final answer for the y will be equals to negative 2 and also y equals to 3. Then for this question, they are asking us for the coordinate of the intersection point. Besides getting the value for the y, you also need to continue to get the value of the x. And I'm trying to substitute into 2x equals to negative y minus 4. And x will be equals to negative y, right? So negative y minus the 4 divided by the 2. And the x value will be equals to negative 1 for this part. And then for y equals to 3, apply the same thing here. X equals to negative y minus 4 divided by 2 as well. And what's the value for the x that you get? It will be negative 7 over 2. And they're asking for the coordinate for intersection point, right? So I would strongly suggest you try to rephrase your answer again in the coordinate form, where the first intersection point will be negative 1 and negative 2. Then the second intersection point will be negative 7 over 2 and also the 3. So this is how we solve question number 3. We are having this the expansion for px squared plus 4x over p power 5. And they tell us that the coefficient for x power 7 in this expansion is 1 to 80. Find the value of the constant p. Okay, for this question, very obvious, it is a binomial expansion. And according to our general formula, what is the general formula when you want to expand a particular term in the binomial expansion? As example, if I say I'm having a plus b power n, the general formula will be NCR, then a power n minus r, b power r. This is a general term, all right? And if you can't remember the formula, basically it will be provided in the formula booklet, which is the MF19. So if you forget, you can just refer it there, right? So now I will show you that this is the general term, yeah? You can have first term. If let's say it is first term, then you start with NC0. Okay, then second term is NC1 and so on, right? And now for this question, they are saying that we want to expand this one and get the x power 7. Can we get x power 7 here? So I try to write the question first, yeah? So I'm having this, then for x over p power 5. General formula for this particular expansion will be 5c something. The something here, I don't know what is it yet. So I leave it blank first. Then a means the whole px squared power n minus r. It should be 5 minus something, okay? I don't know what is the something here, so I just keep it blank first. Then the b is 4x over p. I'm having 4x over p here. What's the power that I want to take here? It is something, but I don't know what is it yet. All right, there are a few ways for you to get the something here. For me, usually I will use trial and error technique, yeah? So use the trial and error technique. You can try out the power one by one and see how can you get the x power 7. But at the same time, when you are having the power here, these two power for the a and b, adding up together must be equals to the 5 for this case, right? Equals to the n, equals to the 5 for this case, right? So let us try. Can I have 1 and also the 4? Because 5 minus 1 is a 4. If I put 1 and 4 here, for this bracket, I'm having x power 1. For this bracket, I'm having x power 8. Because x squared with a 4 outside is x power 8. Then multiply with x power 1, you are having x power 9 already, which is more than x power 7 that we want, right? So it shouldn't be a 1 and 4 here. Then you can try another one. How about the 2? 2 and also 5 minus 2 is a 3, right? Then you double check x squared with a power 3 and also x with a square outside. So 3 times 2, you get power 6. Then x squared is a square. Therefore, when you combine them together, it will be x power 8, which is also not the 7 yet. Right, then we increase the power at the back again. So we increase it, become the 3. Then this one will become a 2, right? Okay, then have a look for this one. You are having x squared with a square outside. And then after that, for this particular x here, I'm having x with a power 3. If you simplify them, you'll be having x power 4 with also x power 3. Multiply them together, you'll be having x power 7. Oh, so this is what we want, because in the question they are giving us with the coefficient of x power 7. And now we know that to get x power 7, the power that I need to put for the back one, okay, at the back one, or the value of the r should be a 3. Okay, so this is how we try it now. Usually, if you have experience, right, you will roughly know, okay, what is the value that you should put. Then you can try from the value from there. So you need to always start from the smallest value and then you try one by one. So you can maybe start from some value that you suspect that is the correct answer, then you just try out, right? Okay, so just now you know that this must be a 3. This one is a 2, right? 5 minus 3 is a 2. And then the r here will be a 3. Okay, then now, after you confirm the power already that you want to calculate, then you just try to expand everything here slowly by using calculator. So 5c3 is a 10. Then for the second term here, you're having p squared multiplied with x power 4. Then the last term here, you're having 4 power 3. So 4 power 3 will give you 64 with x power 3, then divided by p power 3. Then we try to simplify all the terms as much as possible. So as far as possible. So we're having 640 divided by p. Because p squared divided by p power 3, you get a p at the bottom, right? Then x power 4 multiplied by x power 3, you will get x power 7. Okay, and now what is the coefficient of x power 7? So coefficient for x power 7 basically means the number in front of the x power 7. And they are telling you that this particular number here is equals to 1280. So we just try to compare the coefficient with the coefficient, where I'm having 640 over p equals to 1280. And what do I get for the value of the p? So p will be equals to 640 divided by 1280. Simplify it further. What is the answer that you get? If you don't do any careless mistake by right, the answer should be a half. So this is how we solve question number 3. Question number 4. There's a point P moving along the curve with this equation in such a way that the x-coordinate of the P is increasing at a constant rate of 5 units per second. Right. And when you look at this question, right, they are talking about the rate. Can you see the keyword rate? So basically, this is a rate of change question. When you are seeing anything with the rate, right, that means when you want to write it out in the symbol form, you will get the equation or expression with something over dt. Because usually when we talk about rate, it is over the time. Over time means that you are having something over dt. And for this expression or this statement, they are talking about x coordinate, the rate of the changing for x coordinate. Therefore, the variable on top should be dx. So we're having dx over dt equals to increasing, means it should be a positive value. Then what is the value for the increasing? It is 5 units. So dx over dt equals to positive 5. This is the information that you can get from this question here. And the p is moving along the equation. And now let's have a look. Find the rate, highlight the keyword rate again, which the y coordinate of p is changing when x equals to 9. So for this question, they are interested to find out what is the rate of change for the value of the y. So we want to find out dy over dt. Okay, how can I get the dy over dt? So dy over dt is my final answer, right? It should be equals to dy over something multiplied with something over dt. And what's the something here? According to what you have in the question, you're having dx over dt, right? And it is quite obvious that you have to put in the dx over dt here. Then this variable should be also the x. So you need to take the chain rule, okay? dy over dx multiplied with dx over dt to get the dy over dt. Okay? Alright, so dx over dt has no problem because we already have the value with us. And how can we find out the dy over dx? So let's have a look. Is there any important or useful information that you can apply here? We are having this equation, y in terms of x. And if I differentiate this equation, I will get dy dx. So let's do this one now. I'm having y equals to ax power 3 over 2 minus 12x. What is my dy dx here? Okay, so a is a constant. You try to copy it. 3 over 2 is the power you put in front, become 3 over 2. Copy the x, power minus 1, become half. For negative 12x, okay, if you put the power in front, it will be negative 12 multiplied with 1, which is a negative 12. If you copy the x, power 1 minus 1 becomes 0. X power 0 is a value 1. So you have negative 12 for the second term of the differentiation. Right? And now this is my dy dx. Let's put it back into our calculation for dy dx. Dy dt. Alright, so we take dy over dx. dy over dx, according to what we get just now at this part, it is 3a over 2. Then multiply with x power half. What is the value of x that we should take here? It is actually x equals to 9. Can you see that? It is provided in the question. So we are having 9 power half, then minus 12. After that, I need to multiply with dx dt, which is 5. Okay, try to simplify this part slowly. And let's see what do we have here. We are having 9. Square root 9 is a 3, right? So 3 times 3 is a 9. So I'm having 9 over 2a minus 12. Then after that, you have to multiply with a 5. If you try to simplify it by right, you'll be having 9 times 5 is 45 divided by 2a, then minus 60. Yeah, and they tell you that find out the rate of change in terms of constant a, right? And this is what we get. So it will be equals to 45 over 2a minus 60. This is what we have for part A. And let's continue to part B. Now, given that the curve has a minimum point, when x is equals to 1 over 4, find the value of A. Okay, when we talk about minimum point, what do you think about? So minimum point means that it involves the dy dx, and usually when we want to find the minimum point, we'll let dy dx equals to 0. Okay, so this is how we're going to start the question. Alright, so we let the dy dx equals to 0 because of the minimum point, and after that, we can use it to find the value of A. Right. So I know I have to start from here. Dy dx equals to 0. What is the equation for dy dx that you get just now? So go back to the first part just now, part A. Your dy dx basically is this one. Okay, so you substitute into your equation here. And we'll be having this where it is 3a over 2. Okay, then what is the value of the x? Now they say the minimum point, yeah, x coordinate for the minimum point is 1 over 4. That means you have to substitute 1 over 4 into your x, and then you have to take the square root, then minus 12 equals to 0. So this part is my dy dx, and I let it equals to 0. And I think from here it's quite easy. Very easily you can try to figure out the value of the A already. So square root of 1 over 4, you get square root, you will get the half equals to 12. Yeah, so what is the value of A? Very, very easy. So by right, if you didn't do any careless mistake, your value of A should be equals to 16. Alright, so this is how we solve question number 4. Okay, then now we are at question number 5. We are given the equation of a curve, which is something like this. And then the domain for the x is 0 until 2 pi. Okay, state the greatest and also the least possible values of the y. Right, so to find out the maximum minimum point or maximum minimum value, there are many ways for us to do it. Maybe some of us might considering the differentiation, but to differentiate a cost function is not in AS syllabus yet, right? Okay, then what else can we do is that some students might want to draw the graph. That's one way, one possible way. And then for me, usually I will use because it is a cost function, yeah. So I will use the range for the cost function here. Okay, when you are trying to draw any graph for the cost function or cost graph, basically it is bounded between the value of -1 to +1, where maximum value is a 1, minimum value is a -1, right, for the cost graph. Okay, then after that, you slowly transform the cos 2x become the y here. So what are you going to do? For the next step, you have to multiply a 4, right? When you multiply the 4 into the cos 2x, the whole inequality, please multiply with 4 as well. So I'm having -4 until +4. Then next step, what I want to do is I have to add a 3, okay, to make it become the y. So simply happen here, all the inequality value, you have to plus a 3. -4 plus 3, you get -1. And 4 plus 3, you get a 7. And you can see that this is the y. So basically, y is bounded between -1 until 7. So I will just rewrite again. The least value for the y will be equals to -1, and also the greatest value equals to 7. Right, so this is what we have for part A. Then let's continue to part B. For part B, they want us to sketch the curve. Alright, so to sketch the curve, they have given us the axis here. You try your best to sketch it as nice as possible. Alright. Okay, so let's have a look for our graph first. Maybe we need to plan a bit before we can sketch it on this space provided. When I'm having cos 2x, cos x first, let's talk about the cos x first. So for cos x, basically you're having one cycle of the cos graph from 0 until 2 pi. Okay, but when I'm having cos 2x, basically I should be having 2 cycle. Okay, so 2 cycle means that this is 1, minimum point is -1. So 2 cycle means that you should have something like this. Then one cycle complete at pi, then the second cycle start at pi to 2 pi. Okay, so this is the graph for cos 2x. I try to use different color so that you can see clearly. Okay, then next step, what should I have here? I have to multiply the 4, right? When I multiply the 4 to cos 2x, the maximum value or the value of y will be affected. So, as an example, if you're having the maximum value here, which is a 1, when you multiply with the 4, your maximum value will become the 4. Then same thing happen here. Your minimum value originally is a -1, right? When you multiply with a 4, it will affect your y value. So -1 multiplied with 4, you have -4. So your graph become 2 cycle and bounded between -4 to +4. Then next step, to change it become the y, you have to add a 3, right? So you try to imagine you are trying to move this whole graph 3 units upward. So 3 units upwards means that if you're trying to sketch a diagram, right, the -4 here plus 3 become -1. So your minimum point will be at -1. Your maximum point will be 4 plus 7, which is 4 plus 3, which is a 7. And your x-axis originally is a center line of your cos graph, right? You have to move it up, become +3. So 0 plus 3 is a 3. That means your center line here will be a 3. Okay? And then 2 cycle of cos graph, because we're having cos 2x. So now you roughly know how the graph looks like already. Then let us try to put it in the space provided. Okay? Right. So let's start, yeah? So you need to plan a little bit before you can start drawing it. Alright, so I know that my minimum point here will be at -1. So maybe I put a -1 here. Okay, then I have a 7. Then between -1 to 7, there are 8 units, right? So the center line will be a 3. So I put a 3 here. Assume that this is a 3. This is my center line for my cos graph. Because we are trying to move the whole graph 3 units up, right? So the original center line is x-axis. When you move up 3 units, it will become y equals to 3. Okay, so this is the center line. If you don't want to draw it, it's okay also, but it will, I think it will be very helpful if I draw it out. Okay, then now you need to remember that my first cycle will end at pi. Then the second cycle start at pi. Okay, right. So let's start. The first cycle value, the very first value should start from 7, the maximum point. Then comes to 0, comes to the line value 3, okay, which is the center line, right? At pi over 4. This is pi over 4. Then come to the minimum point. Yeah, so as a minimum point, it is at -1. So this is a -1 at pi over 2. Go up back to the center line, which is at 3 pi over 4. Then go back to the maximum point at pi. So this is the complete one cycle of cos graph here. Okay? Then you repeat the same thing for the second cycle. Come back to the center point. Come back to the minimum point, which is -1. Then go back to the center point again, center line. And after that, you go up to the maximum point one more time. And if you try to join all the points together here, it should look something like this. I can't draw it very nicely again. So for you, you can try to draw it as nice as possible, right? Okay, so if you try to draw it, you can see that this is a one cycle of the cost graph. Then the second cycle is this one. So this is how your graph should look like. My graph is not perfect, but at least you can see that I try to show at all the important points here. Okay? Yeah. So you double check, do you have two cycles from 0 to 2 pi? Yes. And then is it your maximum point at 7? Is it your minimum point at the -1? Is it your center line at the y equals to 3? And basically, this is how we sketch the part B, okay, for the graph. Then let's have a look for part C. For part C, they're asking the number of solutions of this equation between 0 until 2 pi. All right, then now, to find out the number of solution, right, we have to look at the number of intersection point. Intersection point between the two graphs. Between the first graph, which is y equals to 4 cos 2x plus 3, and also the other graph is y equals to 2x minus 1. Okay, so you need to see, if I try to draw these two graphs together on the same axis, how many intersection points are there? If let's say one intersection point means that this equation is having one solution or one root. Okay, if let's say you're having two intersection points, then basically you're having two solutions or two roots. All right, and now we have already sketched the graph 4 cos 2x plus 3 in our part B, right? This is our 4 cos 2x plus 3. Let's try to sketch y equals to 2x minus 1. When you want to sketch y equals to 2x minus 1, you assume that you need to take two important points, maybe the x and also y-intercept. If you take x equals to 0, your y-intercept will be -1. So you have one passing point here for the linear equation or linear line. And after that, if you let y equals to 0, your x will be half, which is 0.5. Okay? And you can try to find out the value for pi over 4. You try to press calculator and see what's the value for pi over 4. It should be something more than 0.5, right? I didn't press out properly, so let us try pi over 4. You will get something like 0.785. This is 0.785. If you want to draw the value of x, which is equals to half, so you can just approximately draw it. So maybe the 0.5 will be somewhere here. Okay, so this is the x and y intercept for the linear equation that I have. Then after that, we try to join the point together by using a ruler. Okay, then go to the end, go till the end. All right, so after you draw the line, then let's have a look how many intersection points are there between the graph of y equals to 2x minus 1 and also the graph for the cost. So let's have a look. This is the first intersection point, second intersection point, third intersection point. So you can see that there are 3 intersection points here, right? And therefore, you can just directly write that there are 3 solutions. You can just tell them the reason because there are 3 intersection points. Okay? Yeah. So this is how we get the number of solution. By using the diagram, you have to see how many intersection points are there. All right, so there's a small reminder here. When you want to use this graph to estimate how many solutions do you have, although it is just an estimation, please make sure that you try to draw your graph as nice as possible. That means at least your scale, okay, and also the ratio of the scale or of the axis. Please make sure you use the proper ratio and also the proper scale, right? At least it must look logic, right? Then only they will provide you with a clear solution. So for this question, you can see very clearly that I'm having 3. If the ratio is out, it is possible that they might give you a false result when you try to draw the diagram. So please make sure that you draw it as nice as possible, I would say. Okay? Yeah. So this is how we solve question number 5. Question number 6. The diagram show the curve with this equation and also the line. I think it's quite obvious, right? This is the curve and this is a line. Huh? The line and the curve intersect at the point P when it has the y coordinate of 3. And now they tell you that this intersection point, the y coordinate is basically 3. Oh, I can't draw it nicely, sorry. So you just use a ruler to draw it out. So I just want to tell you that the y coordinate for the intersection point is basically the 3 here. Okay, then now they want you to find the area of the shaded region. Okay, so let's have a look for the shaded regions here. Okay, mainly it is bounded by x-axis. Alright, of course it is also bounded by the y-axis. And then for the curve on top, you can see that there are 2 parts of the shaded area. Basically, they are covered by different curves. The first part of the area is covered by the curve, is under the curve. This is the curve, right? Until the intersection point. So I will say this whole part as part number 1. The first area, which is under the graph of the curve. Okay, then after the intersection point, the area is basically under the line equation. Can you see this is a line, right? This is a line equation. And then if you observe it, basically this is a right angle triangle. So for this second part of the area, you can use a triangle formula, the area of the triangle formula to calculate the area. And we separate into 2 parts. First part, under a curve. To get the area, you have to apply integration. Second part, it is under a line. Of course, if you want to integrate, the line also can. Alright, but for me, because it is a nice right angle triangle, so it is easier for us to apply the area for the right angle triangle to get the answer, which is much more easier, I feel, right? Okay, and now, if I want to apply integration to find the first part of the area, I need to know what is the lower limit, where the area starts. So the area starts here, which is the 0. And I also need to know where the area ends for the integration. So the area ends at this point. What's the value of the x at this point? We need to find it out first. Okay, so let us start. So first of all, we want to find the x coordinate. We know that y coordinate is a 3. And what is the x coordinate for when y equals to 3? You can substitute your y into the linear equation. It's easier. So I'm having 3 equals to 6 minus 3x. 3x equals to 3. So x equals to 1. So this value is a 1. Okay, then after that, for the triangle here also, I also need to know what is the x-intercept here, so that later I can calculate the length of the base. So what is the value for x here? Okay, then we continue to calculate. This is the x-intercept, right, for the line equation. So you let y equals to 0, and you try to solve the equation also. You're having 0 equals to 6 minus 3x, and therefore your x is equals to 2. So this is a value of 2. Okay, after I get all the details that I need, then I can start calculating the area. So how should we get the area here? For the area, we involve integration for first part. Yeah, so for first part it is integration. So you start the integration. Lower limit is a 0, upper limit is a 1. And then what is the curve equation? This is what we have for curve equation. I put it into the power form. Yeah, so I'm having 5x plus 4 power negative half. If you bring it out, it becomes negative half, right? The power. Then dx. Then after that, the second part of the area is I want to use half times base. What is the base for the triangle here? So the unit is from 1 until 2, right? X equals to 1 until x equals to 2. So the base value is a 1. What is the height? So the height of the triangle is this length, which is a 3 unit, right? Because the value of y equals to 3. So you're having a 3 here. Okay? And to calculate the total area, you just need to add them together. That's it, alright? So let's start with the integration. 9 is a constant. I just copied it. 5x plus 4 is a bracket, right? So I focus on the power first. Power plus 1 become the half. And I need to divide it by the new power half. After that, you need to differentiate the thing inside the bracket. Differentiate 5x plus 4, you'll get a 5. So you must divide it by a 5 also. Then after this integration, you have to substitute in the value, the limit, 1 and 0. Then plus, the area of the triangle is very simple, which is 3 over 2. Okay, before I substitute my limit into my calculation, into my integration expression, I have to simplify first. I prefer to simplify first. If I simplify the term, right, I will be having 18 over 5. Then now, only I substitute in the value of 1 inside. If I substitute the value of 1, what do I get? So 5 plus 4 is a 9. Square root 9, you get a 3. Or you can write as square root 9 first. Then minus, substitute 0 inside the x, you'll be having 4. Then plus 3 over 2. Square root 9, you get a 3. Square root 4, you get a 2. So 3 minus 2, you get a 1. Then further simplify again for the answer. By right, you will get 51 over 10. Okay, so this is how we solve the question. Alright, and then to solve this question, you have to observe the graph clearly where it is actually consists of two different areas under the two different graphs. The first one is under the curve, the second one is under the line. Therefore, you have to calculate them separately. Okay, so this is how we solve question number 6. So we are at question number 7 now. They want us to prove this identity. Okay, you can start from left to the right or right to the left also can. For me personally, I will start from the left hand side. The reason is because I feel I'm having tangent on the left, right? That if I want to expand it and change it become sine and cos, it's easier. Okay, because to get the tangent, basically you just need to substitute sine over cos. Then maybe you rephrase your expression on the right hand side, then you will be getting this one. Okay, so before we start, of course, you need to recall a little bit about the identity that is frequently used in AS syllabus. We are having the tangent theta, which is equals to sine over cos, right? And also we are having another one, which is the frequently used one is this one. Sine square plus cos square should be equals to 1. Okay, these are the two identities that we are using it very often, right, in our AS syllabus. Okay, so let's start from the left hand side here. We are having tangent theta plus 7. Then divided by tangent square theta minus 3. Okay, so first step, because my answer here has only tangent, has only sine and cos, there's no tangent. That means I want to replace all my tangent by using sine over cos. So that's the first step that I try to take. Okay, so tangent theta becomes sine over cos plus 7. Okay, then divided by the tangent square. So tangent square, you can write becomes sine square over cos square. Then minus 3. Alright, so the very first step that we take here basically is trying to change all the tangent theta becomes sine over cos. Alright, so for the next step, I want to get rid of the denominator. For all this fraction here, you're having the cos theta as denominator here, right? So it's very troublesome. So I want to get rid of it. What I need to do is like, for the whole denominator, I want to multiply it with cos square theta. Same thing happen for the top one. If you want to make your equation balance, the numerator also have to multiply the whole thing by cos square theta. Okay, so when I multiply cos square theta into the bracket, to both the numerator and denominator, what do we have? We'll be having sine square theta minus 3 cos square theta. Then for the numerator on top here, if you multiply cos square to this part, you will be having sine theta multiplied with cos theta, then plus 7 cos square. Right, so from here you can see that we are one step closer to the answer on the right hand side, because now our expression here has only sine and cos. So their answer also only having sine and cos. So let's try to compare our answer with the answer on the right hand side on top. We are having sine cos plus 7 cos squared. So our numerator also exactly the same, sine cos plus 7 cos squared. And for the denominator, you can see from here that 1 minus 4 cos square theta, we are having sine square here. So how can we make the sine square disappear in the denominator? Please use this one where the identity, we are having the identity sine square plus cos square equals to 1. Right, then that means that if I try to replace it, I will be having sine square equals to 1 minus cos square theta. Okay, so this is what I want to replace. Okay, so let's continue for the next step. We are having sine theta cos theta, then plus 7 cos square theta. The sine square, I will replace it by using 1 minus cos square. Then originally I'm having the negative 3 cos square theta. I just try to copy them. Okay, so from here I think the answer is very obvious because if you simplify what you have now at the denominator part, then basically we are having the answer that they want us to prove. Okay, so negative cos square minus 3 cos square, then we're having 1 minus 4 cos square. So denominator, I'm having 1 minus 4 cos square. Right, so this is how we prove the identity for part A, for part number 1, okay? Then let's continue to maybe part number 2. Part B, hence solve the equation of this one equals to 5 over tangent for this range, okay, for the data. If you try to have a look for our question on top just now, for first part, they want us to prove that this is actually the right-hand side of our equation on part A, right-hand side. And then what is the left-hand side that we have? The left-hand side that we have is this one, tangent theta plus 7 divided by tangent square minus 3. Alright, usually in first part, when they ask us to prove something, or to prove some result, or maybe to prove some value or to find some value or whatsoever, usually we will need to apply in the second part. So you can see that this is the left hand side, right hand side on the part A, and it is equals to this one, which is the left hand side of the part A. So for this question, when you want to solve it, right, you can directly replace this into your equation here, where I'm having tangent theta plus 7 divided by tangent square theta minus 3 is equals to 5 over tangent theta. Okay, after that, to solve it, of course, you need to get rid of the denominator again. So I cross multiply them to each numerator on each side. And I'm having tangent square theta plus 7 tangent theta equals to 5 tangent square theta minus 15. Alright, then after that, how can we continue further? You can try to group all your equation to one side and observe what do you have. So I try to move all my equation to one side, all the terms to one side. I'm having 4 tangent square theta minus 7 tangent theta minus 15 equals to 0. Do you aware what kind of equation do we have here? If you're not able to see, you can let y equals to tangent theta. And eventually you can see that basically it is a quadratic equation. 4y squared minus 7y minus 15 equals to 0. Okay, so you can continue to solve the quadratic equation. How can you solve the quadratic equation? You can factorize them if you want. If you don't want, then you can just use the formula, quadratic formula to solve it. Alright, then for me, I prefer to factorize it easier. Okay, to factorize it, I will have 4 tangent theta. Then this side is the tangent theta. Then I want to have 3 and 5. I want to have negative 7, right? So it should be negative 12 plus 5. Alright, then continue further and solve the quadratic equation. I will be having tangent theta equals to negative 5 over 4. Another value is tangent theta equals to 3. Alright, then now we are going to solve the equation here to solve for the value of the theta. Alright, there are many ways for you to get the value for theta. Basically, for me, I always refer to the quadrants. Alright, for this question, in our solution just now, in our question just now, they did mention that your theta should be from 0 to 180. So let's have a look. 0 and 180 means the first two quadrants on top, right? I only consider the first two quadrants on top. So for first quadrant, everything is positive. For second quadrant, only sign is positive. To get an answer from the first quadrant, it is actually the theta. And the theta here, I define it as the basic angle. For second quadrant, if you want to get the answer from this part, you have to take 180 minus the basic angle. Okay, so I only show you the solution for these two quadrants because our answer is restricted to this part. Right, then let's have a look for the first equation here. I want to have tangent with a negative value. But before that, let us find out the basic angle first. To find the basic angle, right, you always ignore all the sign when you're having the equation here. So I take tangent inverse 5 over 4. You can see that I ignore the negative sign because to me, the definition for basic angle, it is always an acute angle in first quadrant. Alright, so no matter you have equal sign, sorry, you have the negative sign here, please just ignore it when you want to find the basic angle. Alright, then after that, what is the basic angle that I get for this question? So for this part, I'm having 51.3 degree. And now, let us look for the answer for theta. For this equation, I'm looking for tangent with a negative value. So in which quadrant tangent is negative? So let's go through with the first quadrant first. In this quadrant, tangent is positive, so I don't want the answer from this part. In this second quadrant, tangent is negative, right? Therefore, I want the answer from this part. So how can I get the answer from this part? You take 180 minus the basic angle. Therefore, you take 180 minus 51.3. So for this question, you'll be getting 128.7 degree. So this is the first part. I didn't go through the third and fourth quadrant because they are out of range already, right? Then let's proceed back to the second equation here. Tangent theta equals to 3. So first of all, let us find out the basic angle first. So I'll be having tangent inverse 3. And the basic angle that we get is 71.6. And now let's look for the answer of theta. For this equation, tangent theta is equals to 3. So what is the value here? 3 is a positive value, right? So we are looking for the quadrant where tangent is positive. So first quadrant, is tangent positive in this quadrant? Yes. So if I want to accept the answer, what is the answer here? It should be theta, which is the basic angle. So our theta here will be 71.6. Do I accept the answer for second quadrant for this equation? We are looking for tangent positive, but for this quadrant, tangent is negative. So we don't accept the answer from this part. Alright, so I think this is the only answer that we have. Okay, there are two answers here. So usually for me, I would prefer to rewrite all my answer again to show everything in final step. So I'm having 71.6 and also 128.7. Alright, so this is how we solve question number 7. Question number 8. We are given a diagram with a circle, and then the equation of the circle is this one. And the line is also y equals to negative 2. So there's a horizontal line, y equals negative 2, this one. Okay, the line intersects the circle at the point A and B. The center of the circle is a C. Find the coordinates of A, B, and C. Alright, so I think for this question, very easy. If you want to find the intersection point between a line and also the curve, you just need to substitute the line equation into the curve equation. Then after that, you can get the intersection point from there, right? Okay, I substitute straight away the line y equals to negative 2 into the equation. And what do I have here? I'm having x squared plus negative 2 squared minus 14x plus 8x, 8y, then plus 36 equals to 0. Okay, then we try to simplify our equation here. Okay, then when we try to simplify it, we'll be having this. I'm having x squared minus 14x. Then plus 4 minus 16 plus 36. So simplify, it should be getting 24, right? Then equals to 0. And next one, let us try to factorize them and solve for the x. Okay, I'm having x, then 14 12 and 2. Then minus 12 and also minus 2. From here, you'll get x equals to 2. Then also x equals to negative 12. Okay, then this is the x coordinate for A and also the B. Let's continue to figure out the value of the y, but actually you found that the value of the y is the same, which is negative 2. So from here, you know that the coordinate for A should be 2 and negative 2. Then the coordinate for the B should be 12 and also negative 2. Okay, so we done for part the coordinate for A and B lah. And now we need to find out the coordinate for C. Right, so I don't know whether you are using the formula to find out the center directly from the general formula or not, but for me, I usually will change it become the standard form of a circle, right? Okay, how to change it become a standard form of a circle? So let's say I'm having x squared minus 14x. To change it become the standard form, I will need to completing the square. So completing the square means that I'm having x squared minus 14x, then I have plus something square minus something square. So this is completing the square for the x. Right. Okay, I think it's not enough space. Better I write at the bottom part. Okay, so again, I'm having x squared minus 14x, right? I group all the x together first, then I start the completing square process, plus something square minus something square. So as something here, the something should be the coefficient of the x divided by 2. So negative 14 divided by 2, you should be having negative 7. Then this one is negative 7 as well. Alright. And after that, for the y also, I want to complete the square. So I group all the y together first. I'm having y squared plus 8y. Then, again, plus something square minus something square. So what is the something here one more time? So the something here will be actually the coefficient of the y and divided it by 2. So 8 divided by 2, you get a 4. Then the rest of the equation, the rest of the part of the equation, you just try to copy them. So plus 36 equals to 0. Okay, then after that, how can we combine it become a bracket? So now for the first 3 terms here, you want to make it become a bracket. It is a big bracket, x with a minus 7, then with a square. Then minus 7 square, you'll be having negative 49. Same thing happened for the y also. The first 3 terms that we write out just now, you are grouping them into a big circle with a square outside. Then negative 4 square is a 16, then plus 36. And it is equals to 0. Okay, and from here, we try to move all the equation, all the pure number to one side, purely the number to one side. Okay, therefore, I will be having 29. This is a standard form of the circle equation. And from here, basically, we already can figure out the center. The center will be x minus 7 equals to 0, x equals to 7. Y plus 4 equals to 0, so y equals to negative 4. Okay? We are done for finding out the coordinate for A, B, and C. Alright, then let's continue to part B. Okay, for part B, now they said find the angle ACB in radian. Give your answer correct to 3 significant figure. Alright, so angle of ABC. ABC, if you look at it, now basically it is a triangle. Let us try to draw out the triangle first. Let's say this is my A. This is a B. And let's say this is a C. Okay. By right, C should be at the same x coordinate with the center of AB. Because C is the center of the circle, right? When you draw a perpendicular line from C to the chord AB, okay, it is actually the perpendicular bisector of the line AB. Okay, so this is a C. Alright, so you should know that these two are the same distance. Okay, then now I will label the midpoint here as the M for the calculation easier later. Alright, for A, I'm having 2 and negative 2. For for B, I'm having 12 and also negative 2. What is the coordinate for the C? C is 7 and negative 4. Okay, then how can I find the angle ACB? So ACB means A, then to C to the B. Okay, and after that, what else do I have here? I actually know that this one. Okay, there are many ways for you to find out. I will want you to refer to this triangle here. I want to refer to half of the triangle here first. Okay, so for this triangle, I find out this theta first. Then the angle ACB is 2 times of the theta. Agree? Alright. So how can I find the theta? By looking at this triangle, right? There are many ways for you to do it. If you want, if you're aware, you will know that, oh, the length for AC is the radius, which is square root 29. Okay? Or maybe you can have a look for the y coordinate between the M and also the C. So M, the y coordinate is negative 2. C, the y coordinate is negative 4. So what is the length between negative 2 to negative 4? It is a 2 unit length. Okay, so you can use the ratio of a triangle and also the theta to find out the theta. Alright, so like for this one, I can use cos. Okay, where if you try to write out cos theta is basically equals to 2 over square root 29. It will be adjacent over the hypotenuse, right? So the radius here is the hypotenuse. Therefore, your theta will be cos inverse, then 2 over square root 29. And what is the angle ACB? So the angle ACB is 2 times of this, 2 times of theta. So 2 times of cos inverse 2 over square root 29. Okay, then we just try to press calculator and see what is the answer that we get. Alright, so cos inverse 2 over square root 29. Cos inverse answer multiply with a 2. Alright, you double check and see whether you get a long list of value or not. It should be 2.380579899. Then you double check one more time. Sorry, our answer must be correct to 3 significant figure, right? So you just put it as 2.38. Okay, so this is how we find out the answer for the angle ACB. And besides the length of 2 and also the square root 29, right? Some students will ask, can I use the distance from A to M? Also can. Because from A to M, what's the distance here? From A to B, the distance is 10 unit. So from A to M, the distance is 5 units. So some students use the tangent for the theta also can. If you want to use the sine for theta also can. Alright, so basically there are many ways for you to find out the theta. Alright, yeah, so let's continue to part C. For part C, they are saying that the chord AB divides the circle into 2 segments. Find the area of the larger segment. Alright, then let's have a look to the diagram again. What is the area of the larger segment? So the larger segment means this one. Big one here. Okay, so to find the big segment here, the area, how can we find out basically? Alright, so I need you to visualize it first, yeah. Okay, this is the center, right? The A, C, and B straight line will form a triangle. Okay? Alright, so what I want to do now is I try to find out the area of the major sector. This is a major sector. Then you add it together with the area of the triangle. Okay, so from here you can see very clearly that we'll get the area of the major segment. Alright, there are many ways. This is one of the ways. So for me, I'm going to use this method. Alright, and some students, they might think of they are using the whole circle minus the smaller sector, then add back the triangle. Also can. It is another way. Alright, so there are many ways for us to do it. So for me, I will take the major sector plus the area of the triangle to get the major segment. Alright? Okay, then let's continue here. To find out the area of the larger segment, I might need to have this triangle to help me a little bit. So let's copy it down. Okay. Right, so I want to find out the major sector first, yeah? Alright, so before that, let me write it out first. Okay, the area of large segment equals to what? Equals to the major sector plus the area of the triangle. Okay, so what is the formula for the sector? Okay, for the area of sector, the general formula is what? The general formula is half r square theta. Half r square theta. Theta is the angle of the sector, right? Then after that, for the triangle, I think there are many ways. For us, we can use half times base times height here. Half times base times height. Okay? Alright, so let's look for the major sector first. We are having half r square theta. Half is half r square. What is the radius for this circle? So like what I told you just now, AC is the radius, and it is actually square root 29. So you have to square it. And what's the theta? For the angle ACB just now, we are having 2.38. Okay? Therefore, to get the major angle, the big angle, this one. So the black color angle here is the angle of the sector that we want to find just now, right? The major sector. So to find the black color angle, basically it is what? It is one circle, which is the 2 pi angle in a circle, minus the angle ACB that we found out just now, which is 2 times of cos inverse, then 2 over 29. Okay, so I hope that you can see that we are having half r square theta. Okay, this is a major sector that we want to find. After that, I want to add the area of the triangle. So for this triangle, right, I know that my formula is half times base. The base means the length for A to the B. So from A to B, it is 10 unit because 12 minus 2 is a 10. And then height, what is the height? Height is the MC. So MC is 2 unit. Okay, so this is basically how we get the area of the triangle. And after that, maybe you have to use calculator, press a little bit about on the calculator and get the answer. First part, if you didn't do any careless mistake, right, you double check and see, do you get this one or not? Then for the second part, the area of the triangle is a 10. Then continue to simplify it. By right, you'll be having 66.6, correct to 3 significant figure. Yeah, so this is how we solve the question number 8. Right, so we are now at question number 9. We are given the equation of a curve such that d square y dx square equals to negative 24 over x power 3. It is given that the curve has a stationary point at this. This is a stationary point, right? Okay, find an expression for dy dx. Okay, so for this question, right, we are given d square y dx square. So basically, we should know that when we are having the second derivative and we want to go back to the first derivative, we have to apply integration, right? Okay, so this is integration. Then same thing happen if I want to go back to the equation of y, we also have to apply integration. Okay, yeah. So let us start. We are having the dy dx. We want to have dy dx. To get the dy dx, I have to integrate d square y dx square, which is negative 24 with x power negative 3. Alright, so let us integrate it. Negative 24 is a constant, so you just copy. Focus on x power negative 3. Okay, power plus 1 become negative 2, and you divide it by a new power negative 2. Then you're having a plus c at the back. Okay, therefore, dy dx is equals to 12 over x squared plus c. And now we need some values here to get the value of the c. So what are information that we can apply at this part? There's one important information given in the question where they say stationary point is this one. So for this one, you should know that the x coordinate is negative 2, the y coordinate should be the 19, right? And when you are having a stationary point, at the stationary point, we should know that the dy dx is equals to 0. Therefore, I can use this information and apply it in our equation here to find the c. So I'm using the idea where the dy dx is equals to 0, okay, and also at the stationary point, negative 2 and also 19. What do I get here for my c? So dy dx equals to 0, 12, copy a 12, x squared, you put it as negative 2 squared plus c. So from here, you actually get your value of c, which is equals to negative 3. Hence, your dy dx equation will be equals to what? It will be equals to 12 over x squared minus 3. So this is my dy dx. Let's proceed to part number B. Now they ask us to find the x-coordinate of the other stationary point of the curve. Determine the nature of this point. Alright, so again, to find out the stationary point, we usually will let the dy dx equals to 0, then we solve it from there. Okay? Right, so we let dy dx equals to 0. Like what we have just now, right? The dy dx is 12 over x squared minus 3 equals to 0. Then I'm having x squared equals to 4. And I'm having x equals to plus minus 4. Oh, sorry, plus minus 2 if you take the square root. And we are already given one stationary point with the x-coordinate negative 2, right? Yeah. So, for the stationary point that we are interested, it will be x equals to 2. Okay, so we take consideration of x equals to 2. What is basically the value of the d square y dx square? Because they ask us to find the x coordinate. At the same time also, they want us to determine the nature of the stationary point. To determine the nature of the stationary point, what you need to do is that you need to find out the value of d square y dx square. If you substitute the value of x into the d square y dx square, and you get a value greater than 0, that means the stationary point is a minimum point. If you're having d square y dx square, which is smaller than 0, then you should know that it is basically a maximum point. So let's try this out in our solution here. I'm having the other stationary point with x equals to 2. And what is the value for d square y dx square if I substitute x equals to 2 into this equation? Alright, so d square y dx square is negative 24 over what? Over x power 3, is it? Wait, now let me have a look. Yeah, what is my d square y dx square here? It is actually negative 24 over x power 3. So I need to divide it by x power 3, which is 2 power 3. So 2 power 3 will give you 8. If you try to simplify, you have negative 3, which is basically smaller than 0. It is a negative value. So let's have a look here. When you're having a smaller than 0 for your d square y dx square, what is the point, the nature of the point? It is basically the maximum point. So you can just tell them that it is a maximum point at x equals to 2. Okay, this is how we solve part number B. And let's continue to part C. And now they want us to find the equation of the curve. So like what I told you just now, to find the equation of the curve, we have to integrate dy dx. So this is how we get a y. To get a y, you have to integrate dy dx as we get just now. what is the dy dx that we get just now? It is 12 x power negative 2 then minus 3. Okay, so please try the integration here. 12 is a constant. Just try to copy it. Focus on the integration of x power negative 2. Power plus 1 become negative 1. So you have to divide it by a new power negative 1. Negative 3, if you want to integrate negative 3, you will get back x here. So you will be having negative 3x, then plus c. Okay, then what are the information that we can use to find out the value for the c here? We are having the stationary point, negative 2, and also 19 just now, right? So substitute the 19 and negative 2 into our equation here. I'm having, sorry, negative 12 over x. So the x is negative 2. Then minus 3, negative 2, and plus c. Try to simplify the equation. And from here, if you didn't do any careless mistake, by right, your c is equals to 7. Alright, then we rewrite our equation again. So our equation is y equals to negative 12 over x. Okay, from here you can see it is negative 12 over x, then minus 3x, then plus 7. Alright, yeah, so far all these question here until this part is quite straightforward, right? Then let's continue further for part B. Now they want you to find equation of the normal to the curve at the point where dy dx equals to negative 9 over 4 and x is positive. Express your answer in this form. Alright, so first of all, you need to know that when they are giving you the value of dy dx equals to something else, this actually have a meaning of the gradient of tangent to the curve. But now they want you to find the equation of the normal, right? So by using this information, you need to find the gradient of normal later. So that's one part. Okay, when you want to form the equation of tangent or equation of normal, you basically need to know what is the passing point that lies on the curve and also on the tangent or the normal. So maybe for me now, I want to find the passing point first before I can form the equation. Right, so to find the passing point, I just try to solve it by using the dy dx here. My dy dx is having the equation where it is equals to 12 over x power 2 minus 3, right? You can get this from part B just now, or part A just now, sorry. Okay, then now substitute negative 9 over 4 into your dy dx. So I'm having negative 9 over 4, 12 over x squared minus the 3. Okay, then try to simplify your equation and solve it. 12 over x squared, I'll be having 3 over 4. And from here, I can see that x squared is equals to 16. And for this question, they are talking about the positive value of x only, right? When you will try to solve this equation, you will be having x equals to plus minus 4. But we only consider the positive value, therefore I only take consideration of x equals to 4. Alright, and now if I already know that x is equals to 4, next one I want to find out the value of the y. How can I get the value of the y? Substitute x equals to 4 into my equation of the curve, which is this one. Alright, so I'm having y equals to negative 12 over x, which is negative 12 over 4, minus 3x, then plus 7. And if you try to simplify this part, you'll be having negative 8. Okay? Alright, so I have the gradient of the tangent, I have the passing point, and now I need to have the gradient of normal. How can I get the normal? So we basically know that normal and tangent are perpendicular to each other, right? Therefore, the product of these two gradients should be equals to negative 1. If the gradient of tangent is dy dx and you know that it is negative 9 over 4, therefore the gradient of normal will be equals to positive 4 over 9. Okay, and now before you can form any linear equation, you need a gradient. So we are having the gradient of normal. We need a passing point. We also have the passing point where x is equals to 4. The y coordinate is equals to -8. So now we can start forming the equation of normal now. Okay, the general formula that I'm using is y minus y1 equals to m, then x minus x1. Okay, substitute the y1, which is the y coordinate, -8. Gradient is 4/9. x1 is a 4, the x coordinate. Right, then you try to simplify it. And don't forget about the requirement of the question, yeah? They want you to put it in the general form. Multiply the 9. The whole equation, yeah? And after that, rephrase your answer. So if you don't do any careless mistake, by right, when you rephrase your answer, it should be 4x minus 9y minus 88, and it is equals to 0. Okay, so this is how we find the equation of normal and how we answer this question number 9. Okay, and we are now at question number 10. We are given first, second, and third terms of arithmetic progression. This one, highlight the keyword arithmetic progression. Then these are the arithmetic progression, okay? The first, second, and the third term, where k is a non-zero constant, so should be not equal to 0. Find the value of the k. Alright, so I want to use the property, some simple rules about the arithmetic progression. So the arithmetic progression means that you are adding a common difference to every term, right? To get the later term. So that means if I want to get the common difference, I need to take the second term minus the first term. So I'm having k squared minus 4k. And it should be equals to the third term minus the second term. Okay, so this is the formula for common difference. Second minus first or the third minus second. And the common difference should be the same throughout the arithmetic progression. Alright, then we try to solve the question from here. I'm having 2k squared minus 12k equals to 0. Try to factorize it. And you are getting the value of k equals to 0. And of course, we have to ignore this one. And after that, we are having k equals to 6. Right, so we actually want this value. Our k is equals to 6. Okay, then how about for part number 2? Now they want you to find the sum of the first 20 terms of the progression. Okay, before you can find out the sum of the first 20 terms, I need to know what is the value for my AP first. Okay, so let's have a look for our question just now. My k is equals to 6, right? First term is 6 times 4, which is 24. Second term will be k squared, which is 36. And the third term, what do we have? We are having 8 times k. So 8 times k will be 48. These are the first 3 terms that I have. From the first 3 terms here, you already know that I'm having the first term, which is the a, is 24. And now, if I wish to get the value of the d, the common difference, you should take the second term minus the first term. So your common difference is actually a 12. Alright, and now let's calculate the sum of the first 20 term. Sum of the first 20 term. What's the general formula? Do you still remember? Okay, so in the arithmetic progression, when they are talking about the n term, but we didn't use n term here, right? So when you're talking about n term, it should be a plus n minus 1d. If they want you to calculate the sum of the first n term, the general formula will be n over 2, then 2a plus n minus 1d. And now we are going to look for the sum of the first 20 term, right? So we are looking for this formula. So s equals to 20, s20 equals to, n is 20, so 20 divided by 2. 2 multiplied with the a, what's the value for a? 24. What's the n? 20. 20 minus 1, you get 19. And what's the d? d is 12. Just try to substitute all the value in and simplify it. by right, you should be getting this one, 2760. Yeah, and this is what we have for part number 2. And let's proceed to part B. So for part B, they are talking about another progression now. The fourth and also the sixth term of a geometric progression are 36 and 6 respectively. Common ratio of the progression is positive. Find the sum to infinity of the progression. Give your answer in this pattern. Right. Again, for now, it is different from what we have just now. Just now is arithmetic progression, and now we are having the geometric progression. Let's recall back again. What are the important formula under the geometric progression? First, talking about the n term. The general formula for n term will be AR power n minus 1. The second formula will be sum of the first n term. We are having A, 1 minus r power n divided by 1 minus r. And for geometric progression also, we are having the sum to infinity, where it is A divided by 1 minus r. But you need to know, for the sum to infinity, right, it cannot apply for every single cases. It can only appear when your modulus of the r is smaller than 1. Okay? Yeah. Then all this formula, if you can't remember it, no worry, it will be provided in the formula booklet. So you can always refer back to the MF19. Right? Then let us try to set the question here. They are talking about the fourth and also the sixth term. Fourth term means T4. And T4 should be equals to given 36, right? Put in the formula into the T4, I will be having A. I don't know what is the first term. I also don't know what is the R, but I know that it is power 3 because 4 is n minus 1 is a 3 equals to 36. Then maybe I make this one as a first equation first. And now for the second information, they say sixth term. So T6, what's the value for T6 here? It is equals to 6. Write out the formula for the T6, it should be AR power 5 equals to a 6. And this is my second equation. To find the sum to infinity, if you have a look here, definitely I need the value for A and also the R, right? Okay, so we try to solve this equation simultaneously to get the value for A and also the R. And how can we solve it? What you can do now is you try to divide. I take equation number 2, divide by equation number 1. And the right hand side will become AR power 5 divided by AR power 3. Then the right hand side is actually 6 divided by 36. When you simplify your right hand side or left hand side is r squared. Right hand side will be 1 over 6. When you want to take the value of the r, you want to take square root, right? So by right, you should be having 1 over square root 6 plus minus. But for this question, they did mention also, right? The common ratio must be a positive value. Therefore, we only accept the r, which is equals to 1 over 6. Okay, then now let's answer the question. We already have the value of, sorry, I don't have the value of A yet. So let's find out the value of the A. How can you find the A? You can substitute your R into either the first equation or the second equation. So up to you, alright? So you can see what do you want. So for me, I'm using the first equation. Get the A, it is equals to 36 divided by the R power 3. So I put 1 over 6 power 3 here. Try to use calculator to help us a little bit. By right, you'll be having 1296 over 6. Okay, you can use calculator to help you a bit. So this is my first term A, and my common ratio is 1 over 6. Now let us proceed to find out the sum of infinity or sum to infinity. To get a sum to infinity, the general formula is A divided by 1 minus R. What is the A here? My A is this one. What is the R? So basically R is 1 minus 1 over square root 6. Okay, so what's the very troublesome part here is the square root 6 as the denominator, right? Okay, I need to rationalize it, or maybe I need to get rid of the 6. So to get rid of the sub-6, what I do is that I multiply my whole equation top and bottom, the expression, the fraction top and bottom by using the sub-6. Bottom also the same, so that your equation or your expression is still a balanced one. Okay, multiply the sub-6 inside, you'll be having 1296. Multiply the sub-6 inside the answer, the denominator you're having sub-6 minus 1. And if you double check the answer again, you will see that it is exactly the pattern that they want us to show here. Alright, so we will stop here for this question because this is the answer already. So any problem so far? I think it is not too hard, right, until this question. And this is how we solve this question number. Okay, so now we are at the very last question for this paper. They want us to express this quadratic expression become this form. So very obvious it is a completing square form, right? Okay, so let us start. To complete the square for a quadratic equation, I group all the x together first, where I'm having x squared plus 4x, and after that I have to plus something square and then minus something square. So again, what's the something here that I should put inside the bracket? It is actually the coefficient of x, then you divide it by 2. So you are taking the 4 divided by 2, therefore you're having the 2 here. Then the plus 2 in the original question, you just try to copy it. Okay, then after that, the next step, we are trying to combine the first 3 terms in our step just now into a big bracket. First term is the x, and the term at the back is a 2 with a square outside. Okay, then minus 2 square is a 4, then plus 2. Then try to further simplify it. This is what you should get here. Okay, so it's a straightforward and easy question. Then let's continue further to part number B. Now they are giving us some function here. We are having the function fx and also the function gx with a respective domain. Find an expression for f inverse x. Okay, so to find out the inverse function for any quadratic function, for any quadratic equation or quadratic function, basically you have to start with the completing square form. And if you try to compare this and also what we did in the first part, basically we already get a completing square form just now, right, in part A. So we are using this form to find out the inverse function. Okay, so let us start. I will let y equals to the inverse function, let y equals to the original function that we have, but I want to put it in the completing square form. So it is actually x plus 2 square minus 2. So this is how we begin, right? And our aim is to change the whole equation here, become x equals to something something y. And I need to move all the numbers slowly to one side and keep the x on the left. So I want to have y plus 2. After that, I take the square root. When you take the square root, of course, you have to consider the plus and minus sign. And what's the value for the x here? The x here, you move the 2 over, become negative 2, and you're having this as your solution. But before we can decide what is the last, what is the only inverse function that we have here, you need to know that for this step, you are having 2 answers basically. I'm having negative 2 plus square root something, and also minus 2 minus square root something. Okay, we are having 2 functions here, but for inverse function, you can only choose one of them. So only one will be the correct answer. So why we need to choose only one answer? It is because of the inverse function. It must be, to find the inverse function, your original function must be 1 to 1, right? Yeah. So same thing happen here. When you want to get the inverse function, you must only have one answer, cannot accept both of them. And how can we choose what is the correct function for this one? You need to know that when we are looking for this, it is actually the range of the inverse function, and it should be equal to the domain of the function. What's the domain of the function here? It is actually x smaller equals to negative 2. And try to ask yourself, for these 2 functions here, which one will give you something that's less than negative 2? Negative 2 plus something will give you something more than that. Then negative 2 minus a number, they will give you some value that is less than negative 2. Therefore, this is the correct answer. Okay? And after you decide the correct final answer for inverse function, please rewrite again nicely. And this is what you have. So this is basically the inverse function for the f. Right. Okay. Then let's continue further for part number 2. And now they want you to find an expression for GF inverse x. So how can you find out the GF inverse x? There are basically two methods here. To find the GF inverse x, maybe you can find out the GF first. Then after that, only you find the inverse function for this composite function. That's the first method. Alright. Then another possible way is you need to know there's a formula here where you are having an inverse function, right? And you put it in, it will become F inverse G inverse. That means you try to find the composite function of G inverse come first, followed by the F inverse also can. It is another method lah. So for me personally, I'm finding out the GF first, the composite function first, then only found the inverse function of the composite function. Okay? And let's start now. To find out the GFX, substitute the x into the function g. What's the function f that I have? Again, I prefer to use the completing square form here, so that I think later it will be easier for me to simplify it. Okay, so this is the function f, right? Then you want to put this function inside the g. So what is the function g just now? Let's have a look again for the function g. It is negative x, negative 4. So I had to put negative. My x now is this whole thing, right? So you put in the x plus 2 square minus 2. So this is negative x, then negative 4. Okay, so try to have a look for this one. By right, you should be getting negative x plus 2 square, then minus 4. So this is my inverse, this is my composite function GF lah. But now we want to find the inverse function of this composite function. And again, we repeat the same step like just now. We try to let y equals to the particular quadratic expression first. And we put it in this form. This is the completed square form, right? Okay, then again, try to change your equation, become x equals to something, something y. So let's start. I'm having, okay, maybe I put it like this. I move the x plus 2 square over, then I'll be having negative 4 and also minus the y. And now I want to take the square root. I have to consider both plus and minus sign. Then I move the 2 over again, it becomes negative 2 plus minus square root of negative 4 and also negative y. Okay, then again, now I want to decide also, because for until this step, I'm having two possible answers for the inverse function. So I'm having negative 2 plus square root something, and also negative 2 minus square root something. So which one do you think that it should be a correct value or the correct function to be chosen? Yeah, right. So again, you need to know that this whole thing basically is talking about the range of the inverse function GF. And it is basically equals to the domain of the composite function GF. And now, for the domain of composite function GF, yeah, so what would it be? So you try to imagine for a composite function GF, right? Which one start first? Yeah, the function f start first, followed by the g, right? Therefore, the domain of the GF is actually equals to the domain of f. So let's have a look again. What is the domain of the function f here? Smaller equals to negative 2. Go back to the question, then you ask yourself again, which function will give you something smaller or equals to negative 2? This one, right? Okay. And now let us rewrite it again. The composite function inverse for GF is equals to -2 minus, change the y become the x, so -4 minus the x. Alright, yeah, so this is how basically we try to find out the inverse function. As long as you want to find the inverse function that involve the quadratic expression, then definitely have to start by using the completing square form. There's no other method, right? Okay, so this is the end of the video. Thank you very much for watching the video. And please share out the channel if let's say you found that it is useful for you. Thank you very much.